So here we have the question number 2, part A. Figure 8.1 shows 3 lamps and fuse connected to a power supply. So this is a power supply and you have 3 lamps connected in parallel with respect to one another, and they are connected through a fuse. The EMF of the supply is 220 volts. Okay, each lamp is labeled 220 volts, 40 watts. The rating of the fuse is 2 amperes. Okay, so fuse is just a safety device. So in the calculations, you can even ignore it when you're trying to find the current, the voltage, or the resistance. You can ignore the fuse because it's just a safety device, and we assume that there is no voltage drop across it, so it's not even there. How much voltage is being supplied to each of the lamp? 220 volts, because all 3 of them are connected directly to the battery, and all 3 of them are parallel to one another. So you get 220 volts across each and every one. And the power rating of each and every fuse is 40 watts. So you do have the value of power. Power equals to 40 watts. And you do have the value of voltage, that is 220 volts. Now you can find the current in each lamp by using the formula P equals to VI, and from there I equals to P over V, and that would be 40 divided by 220. Then you hit it on the calculator. Let me know what do we get from here. Yeah, this is the answer for this one. 0.18 ampere. Okay, 0.18 ampere. So 0.18 ampere is the current that each of these lamp is drawing. So 0.18 ampere goes over here. Likewise, 0.18 ampere walks to the other one. And likewise, 0.18 ampere walks to the third one. In all of that, current is coming from the battery, and the collective current must be flowing through the fuse, because that's the same current, and only at this point the current is divided into 3 equal paths, 3 equal parts. 0.18 goes to the first one, 0.18 goes to the second one, 0.18 goes to the third one. But previously, all of the current was collectively flowing through the fuse. So how much current is there in the fuse? You can add all of them. 0.18 plus 0.18 plus 0.18, which would be 3 times of 0.18, and that would be 0.5. Round it off to 0.54. Okay, then we have the total number of lamps all in parallel that could be connected without blowing the fuse. Okay, what we can do is the current in each lamp was 0.18. We know this is the value of current in each lamp. If you connect if you connect 2 lamps, the total current would be 2 times of 0.18. If you connect 3 lamps, the total current would be 0.3 times of 0.18. But how much current fuse can handle? It can handle 2 amperes. Lamps, and here we have current. So for one lamp, the current was 0.18. For how many lamps? For X number of lamps, the current would be 2 amperes. Like for 2 ampere of current, how many lamps would be there? And after that, you can simply cross multiply like this. Sorry, X into 0.18 equals to 2 into 1, and from there X equals to 2.0 divided by 0.18. Then you hit it on the calculator. Let me know what do we get from here. Over to the next one. After a very long period of use, the wire filament of one of the lamp becomes thinner, underlying the effect of this change on the resistance of the filament. So area of cross section decreases. That's why it becomes thinner, or it becomes thinner, then we can say the area of cross section has decreased. And if the area of cross section decreases, now your road is narrow, the resistance would be more because the traffic would be bumping into each other. Just an analogy, I mean, it would be electrons, but for the analogy, the traffic would be bumping, the vehicles would be bumping into one another, so the resistance would increase. All right, then we have the next one. State and explain the effect of this change on the power of the lamp. So your resistance increases. What would be the effect on power? So let me write down the formula of power first. Power equals to the ratio of the product of voltage and current. So what's happening is the resistance increases. So if the resistance increases, what would happen to the current? Current decreases. And if this thing is being decreased, the current is being decreased here, the power would also be decreased. So as current decreases due to increase of resistance, the power also decreases. The power also decreases.